Hi everyone, thanks for watching. In this video, I'm going to show you how to actually write some different examples of transmutation equations on your own. So first, just remember that these transmutation equations are simply ways to model and describe how unstable nuclei decay, also can be used to represent other nuclear changes. And the first one we'll do is a simple alpha decay like you saw in the last video for the atom nickel-60. So to start off, remember we write the equations almost like a before and after, and before the decay happens, all you have is an atom of nickel-60. So we just need to write the isotopic notation for it. If you go to periodic table and look up nickel, you see its atomic number is 28, which allows you to actually write the before isotopic notation for nickel with an atomic number of 28. And a mass that's given in the hyphen notation as 60. Following that, you put the arrow to represent that atom of nickel-60 decays. And it's going to decay into two things. One of them is given in the problem itself, and that's the alpha particle. Alpha particles are made of 2 protons, which is He, the symbol. You remember, here's our list of symbols from last time. Alpha particle, He, 2 protons with 2 neutrons, giving it a mass of 4. I actually leave off the charge because it just kind of complicates things. And then once that alpha particle leaves, it's going to leave behind a smaller nucleus. Remember from the last video that the atomic numbers and masses are always equal. So if we started with an atomic number of 28, I have to have at the end an atomic number of 28, which means this new nucleus only has 26. 26 plus 2 is the 28 you started with. The masses work the same way. We started with a mass of 60, so I need to end with a mass of 60. The alpha particle took 4 AMUs of that mass, leaving behind 56. The final step being to figure out what new element was created here. With 26 protons now, go back to your periodic table, find atomic number 26, which is iron, and then go back and fill in the symbol Fe for iron. And once you've got that symbol filled in, you're done with the whole equation. In our second example, we'll do a beta decay this time. It'll be the first one of those you've seen of a different element, potassium-40. The first step, just like last time, is to write the isotopic notation for potassium-40, which is K for potassium, 19 protons, which I got off the periodic table, and a mass of 40. Then the decay happens, so we put an arrow. This time it's a beta decay, so we're going to use the symbol for beta instead, which is an electron. Then write the isotopic notation for whatever the nucleus changes into. This one's kind of weird though. Remember, the numbers have to be equal. So if we start with 19 protons, we have to end with 19 protons. But because this is a negative, that means my new nucleus has to have 20 protons. 20 plus -1 gives you 19. It seems weird, I know, but trust the math, it works out. And that is actually what happens in real life. Do the same thing with the mass. We start with a mass of 40, so I have to end with a total mass of 40. Luckily, the beta particle has no mass, so this new particle also has a mass of 40. The final step is to look up what new element has 20 protons, which happens to be calcium, and that completes the whole equation. So now that you've seen me walk through 2 of these, it's a good time for you to pause the video and try a couple on your own to see if you get it. And then once you've tried them both, hit play again and see how you did. Okay, here's the answers. I'm going to go pretty fast. There is actually an alternate video posted if you need to see these explained a little more slowly. But the first one, the symbol for arsenic-80 is 33 protons with a mass of 80. Then the arrow, it's an alpha decay, so you should have your alpha particle leaving behind 31 protons, making it gallium and a mass of 76. For the beta decay of cobalt-60, before we start with the symbol for cobalt with 27 protons. The decay happens, so put the arrow. This time a beta particle is released, leaving behind 28 protons. Remember, 28 plus -1 gives you the 27 you started with, and the mass of 60. And remember, like I said, if that was a little bit too fast and you want to see that explained more thoroughly, there's a third optional video if you got them wrong, where you can get some extra help with this process. That concludes the video. Thank you very much for watching.